In the beginning, there was only silence, not the kind that lives between sounds, but the kind that exists before time, before light, before even the thought of motion. A silence older than the first atoms, a stillness that wrapped itself around the edges of everything that would one day become a universe. And then, a tremor. It was not light that first stirred, nor matter that first moved. It was gravity, that invisible thread tying together every dream of creation, every promise of collapse. In a far corner of the cosmos, billions of light years away, the fabric of spacetime shuddered. The ripple was faint, almost imperceptible, but it carried the weight of something colossal, something that should not have moved. The instruments that first caught it, vast mirrors buried in silence on Earth, recorded a vibration not of stars, but of existence itself. Astronomers would later call it the tremor in the dark. They traced its echo across galaxies, through clusters, through the cosmic web, like a ghostly pulse that made the universe quiver for the briefest moment. Somewhere out there, far beyond the reach of any telescope, a black hole, ancient, immense, and unyielding, had been shaken. It should have been impossible. A black hole is the great anchor of reality, an abyss so dense that even light cannot escape. It does not move easily. It does not tremble. And yet, something had disturbed it. Something larger and stranger than the equations of physics were ready to contain. In that region of endless night, a supergalaxy stirred, a titan built from the bones of countless smaller galaxies devoured over eons. It was a living continent of stars, a trillion suns orbiting a single heart of darkness. But even it, for all its weight and brilliance, was caught in a struggle it could not fully control. As the supergalaxy drifted through the void, its gravitational tides began to twist and distort its own center. The central black hole, once seated at perfect equilibrium, began to oscillate, a heartbeat too vast for human sense. A rhythm stretching across light years. Astronomers, staring at the data, found themselves facing a question older than science itself. Can something shake the unshakable? Can a creation challenge the force that ends creation? The tremor was real. The silence that followed was deeper. Somewhere in the depths of space-time, a message had been sent, not in words, not in light, but in the subtle vibration of reality itself. And to understand it, humanity would have to trace gravity back to its origins, to learn what binds the universe together and what might one day tear it apart. It began as a whisper, a vibration so faint it seemed almost imagined. In the depths of the Earth's quietest chambers, laser beams stretched between distant mirrors trembled, not from wind or quake, but from something far beyond the planet's reach. In the data streams of observatories spread across continents, LIGO in the deserts of Washington and Louisiana, Virgo beneath the Tuscan soil, a new rhythm emerged. It did not sing in the sharp, rising tones of merging black holes or colliding neutron stars. It pulsed slowly, a low-frequency murmur that lingered like the echo of a drumbeat too large for the sky to contain. At first, it appeared as noise. The instruments that measure space-time itself are haunted by noise, thermal, seismic, even quantum. But this was different. The signal was steady, patient, ancient. It stretched over weeks, months, refusing to fade. Its amplitude was vast, yet soft, like gravity breathing. When cross-checked with pulsar timing arrays, natural clocks scattered across the galaxy, the same pulse was found again. Pulsars, those spinning remnants of collapsed stars, send beams of radio light through the cosmos with precision rivaling atomic clocks. Any ripple in space-time distorts their rhythm ever so slightly, and across hundreds of light years, Many of them seemed to sway in unison. Something enormous had stirred the very architecture of gravity. Scientists convened across time zones, linking data from LIGO, Virgo, and Unanograph, the North American Nanohertz Observatory for Gravitational Waves. What emerged was both thrilling and unnerving. A low, universal hum threading through the cosmic background itself. It was not a burst, not the death cry of a star or the collapse of a binary system. It was continuous, deliberate, as if space-time itself were resonating to a deeper music. The frequency was far too low for ordinary mergers. No single event could have created it. Instead, it hinted at the movement of something colossal, far beyond anything human eyes had ever witnessed. Perhaps to supermassive black holes orbiting each other over eons. Or perhaps something even larger, a galactic structure twisting the geometry of the universe as it moved. Somewhere, billions of light years away, a force was pressing against the dark fabric of creation. And the universe was responding. Images began to form from simulation and inference. Imagine a ripple moving across the cosmic ocean, bending the light from galaxies millions of parsecs apart. It was as though reality itself had flexed an unseen tide passing through clusters, filaments, and voids, leaving the faintest signature on every photon that crossed its path. To most, it was just a data set, numbers dancing across screens. But to those who understood the scale of the signal, it was something else, the breath of a sleeping giant. Astronomers turned their eyes and their instruments toward one direction, the heart of an ancient galactic cluster, catalogued only faintly in infrared. It lay beyond the Virgo supercluster, beyond Laniak, on the outer rim of what some maps call the Hercules Corona Borealis Great Wall, one of the largest known structures in the observable universe. Amid the faint radiation and ghostly outlines of stellar halos, a distortion had been recorded decades earlier, a tiny asymmetry in redshift data that no one could explain. Now, with the new gravitational signal, it took on a different meaning. The light bending, the gravitational hum, the displaced central mass, all pointed to a single possibility. Somewhere within that vast cluster, a black hole had moved. The idea was absurd. Black holes do not move easily. They are the anchors of galaxies, the still points around which trillions of stars revolve. Their gravitational fields are so immense that even the collapse of an entire galaxy cannot shift them by more than a few light. To disturb one would require an equal force, another giant, another heart of darkness. Speculation erupted. Was this the mark of two supermassive black holes locked in a slow orbital dance? A binary system born from a galactic merger so vast that its gravitational waves spanned the entire universe? Or was it something more exotic, an instability within the cosmic web itself, a resonance between dark matter, filaments, and baryonic structures? Theories multiplied like stars. One camp believed the tremor was the long-awaited proof of a population of binary black holes at galactic scales, titanic pairs spiraling toward each other, destined to merge over billions of years. The hum would be the chorus of all of them together, the deep bass line of the cosmos. Another camp whispered of something more singular, an event so massive, so improbable it stood alone. They called it the supergalaxy, a galactic continent born of countless collisions, with a central mass so large it could bend not just light, but gravity itself. A gravitational leviathan that could momentarily destabilize even its own core, sending a ripple strong enough to shake the black hole it harbored. In meeting rooms and observatories, the language of science gave way to poetry. One astrophysicist wrote in his notebook, "If gravity is the universe's language, This is a sentence no one can yet read. Another added, perhaps it is the universe remembering its own construction, the echo of the moment it began. The data continued to stream in. Weeks turned to months. The pulse grew clearer. Its periodicity revealed a cycle, not random, not chaotic. It was structured. Something was orbiting. Something was alive in the gravitational sense. A motion with intent. To visualize it is to imagine two titans in slow embrace, circling each other in the dark. One, a black hole, billions of times the mass of the sun. The other, an entire galaxy, dense and sprawling, drawn ever closer by gravity's unrelenting pull. Each orbit would send out a pulse, a slow, rolling distortion of spacetime, until one day they would merge, and the universe would shudder. But this was not a prediction of the distant future. The data suggested it had already begun. The tremor detected by humanity's instruments was not a warning. It was a memory, the afterglow of an event that happened billions of years ago, now reaching us through the fabric of time itself. The scientists understood the implication. They were not witnessing the event. They were listening to its echo. Somewhere in the deep past, a supergalaxy had shaken a black hole, and the wave it created had just arrived at Earth. Around this realization formed a silence, a human silence, fragile and small compared to the one that fills space. In that quiet, the enormity of the discovery settled in. If such a thing could occur once, could it happen again? Could galaxies so large, so gravitationally heavy, disturb the balance of their own hearts? Could gravity, the force that gives structure to everything itself, become unstable under the weight of creation? The questions reached beyond physics into philosophy. Gravity, the most reliable force in the cosmos, was revealing its own vulnerability. It was no longer the eternal constant. It was a dynamic, restless entity, capable of trembling like the beings it had birthed. The night sky, once a symbol of stillness, now appeared in motion. Every galaxy, every black hole, every filament of light was part of a symphony too deep for ears to hear, but not too deep for instruments to detect. The universe was not silent. It was singing slowly, darkly, endlessly, endlessly, and within that song, humanity had heard, for the first time, a new note, a note that did not fit any known harmony. It was the beginning of a mystery that would stretch across generations, one that would draw scientists closer to the edge of understanding. For if something in the cosmos could shake the most immovable object known to existence, then the universe itself was not a fixed design, but a living, breathing entity, vast beyond imagination, and still evolving in ways no equation could yet describe. And so the search began anew. Every telescope was every gravitational detector reached. The tremor in the dark had become a clue, one that promised to lead not just to the center of a galaxy, but to the heart of the universe's own design. The investigation widened, extending its reach across continents and disciplines. Teams reprocessed years of archival data from every gravitational observatory, layering signals upon one another like translucent maps of invisible motion. The same pulse kept reappearing, faint, deliberate, ancient. Even when filtered through new instruments or analyzed with updated algorithms, the rhythm persisted. It was as though the universe itself had left a watermark in the background noise of reality. At the European Southern Observatory in Chile, deep sky imagers scanned the suspected region. They found subtle irregularities in galactic alignment, light bending more than gravity alone should allow. This lensing hinted at an immense mass hidden behind the glare of a billion suns. Somewhere within that radiance, a black hole was adrift, Not orbiting, not collapsing, moving. The notion unsettled even the most measured minds. Black holes could recoil, yes, if unequal gravitational waves were emitted during a merger. But to observe one still wandering after eons, oscillating within its host galaxy, like a pendulum of dark energy, defied expectation. The calculations showed energy outputs beyond ordinary relativity, hinting at complex interactions between dark matter halos and relativistic motion. Radio telescopes joined the search. The square-kilometer array prototype detected faint synchrotron emissions, stretching outward like tendrils from a galactic core, residual traces of jets that had once burst forth at near-light speed. If these jets were asymmetrical, the recoil could indeed have launched the black hole from its center, sending it oscillating through the galaxy's gravitational field. But this would require a disturbance of near-infinite scale, a surge of energy equal to the collapse of thousands of galaxies combined. The deeper the data reached, the stranger the truth became. The gravitational hum carried harmonics, small repeating patterns suggesting resonance. Something was not just moving through spacetime, it was interacting with it, vibrating against the cosmic medium, as if the universe itself were a living membrane. Each oscillation hinted at communication between structure and void, a dialogue, older than light. This realization transformed the tone of inquiry. What had started as an anomaly became a new frontier. Physicists began to wonder whether large-scale galactic motion could induce gravitational standing waves, ripples that might persist indefinitely, shaping the architecture of clusters. Perhaps this was not a one-time tremor, but part of a continuous breathing of the universe. Cycles of gravitational pressure and release echoing through the cosmic web, dotting conference halls and academic papers. One phrase began to surface repeatedly: the gravitational continuum hypothesis. The idea that at certain scales, matter and space-time behave as a single fluid, capable of oscillation. The discovery of a supergalaxy capable of disturbing its own black hole might be the first observable instance of that hidden mechanic. Late one evening, while recalibrating simulation parameters, a young researcher noticed something subtle. When the signal was inverted, treated not as an emission, but as an absorption pattern, the shape resembled the predicted structure of the cosmic microwave background's oldest cold spot. It was as if the tremor aligned with an echo left over from the universe's infancy. For a brief moment, the entire concept of time seemed porous. The gravitational wave that arrived now might not only describe something happening billions of years ago, it might resonate with something that happened at the beginning of everything. The tremor was no longer just a disturbance in gravity. It was a message carried through the bones of the cosmos, whispering of a universe still moving to the rhythm of its creation, and humanity, fragile and brief as a spark in that vastness, had finally learned how to listen. Across the deep vault of the cosmos, telescopes turned toward a faint distortion in the tapestry of light. It was not a new object, but an imbalance, a subtle curvature that betrayed a mass so great it bent reality itself. What emerged from weeks of observation was a portrait of something extraordinary, a galactic leviathan, luminous with the fire of trillions of stars, drifting through the void like a continent of light. Yet even within that brilliance, something was wrong. Its heart, the black hole that should have anchored its soul, was no longer at the center. Astronomers stared into the data with quiet disbelief. The core of this immense structure was adrift, oscillating thousands of light years from where it should have been. They called it the shaken core, not as poetry, but as acknowledgement that the unshakable had moved. This galaxy, they realized, was not a single being. It was a congregation of hundreds, perhaps thousands of smaller galaxies, drawn together over billions of years, colliding and merging in slow cosmic dances. Each merger left behind its own supermassive black hole, and over time, these dark titans spiraled inward, fusing into one gravitational monarch. But something in this system had gone awry. The very act of uniting may have unleashed a recoil, a cosmic backlash powerful enough to dislodge the king from its throne. Through the vast eye of the James Webb Space Telescope, light from the galaxy's outer rims shimmered unevenly, as though reality itself were vibrating. The core's displacement sent tidal distortions rippling through its stellar disk, rearranging the motions of stars, twisting rivers of gas into spirals that defied symmetry. What should have been an ordered empire of light now pulsed like a living, wounded organism. The data hinted at violence, the echoes of a colossal merger between black holes, each billions of solar masses strong. The combined gravitational waves would have burst outward like invisible thunder, shaking the entire galactic frame. Such events had been theorized, but never witnessed at this scale. It was as though the universe itself had momentarily lost its balance, and yet the black hole did not vanish. It drifted immense, silent, carrying with it a retinue of stars and dust caught in its gravitational wake. To observers, it appeared almost serene, as if gliding through a cosmic ocean, its motion a slow reverberation through space-time. But beneath that calm, the physics was staggering. A displaced black hole could tear through its surroundings, igniting star formation in some regions, extinguishing it in others. It could alter the chemical evolution of the entire system, reshaping the destiny of billions of suns. The galaxy's imbalance was not merely aesthetic, it was structural. Gravitational lensing revealed arcs of light bending around empty space, as if the unseen hand of dark matter had been pulled taut, twisted into new alignments. Some theorized that this event might offer the first tangible glimpse of dark matter's true nature. Others speculated that it signaled a phase transition, a subtle shift in how gravity behaves across cosmic distances. But for all its magnitude, the image carried something almost human, a strange melancholy. Even the universe, vast and indifferent, seemed to echo a truth mirrored in life itself, that equilibrium is fragile, that even the greatest systems can falter, and that motion, not stillness, defines existence. As months passed, astronomers began constructing computer models to rewind the event, to peel back time, frame by frame, and uncover what had shaken the core. The simulations stretched back 10 billion years, tracing mergers between smaller galactic clusters, each collision birthing waves of light and gravity. Eventually, a pattern emerged, a central spiral of immense density forming around a singular gravitational point, then flickering, momentarily splitting before recombining with tremendous force. In that instant, the black hole might have been struck by the recoil of its own creation. Two titans merging imperfectly, their gravitational waves escaping unevenly into the cosmos, imparting a push, a kick, that sent the resulting singularity careening across its galaxy. It was not chaos, it was conservation. Even the universe balances its books. Still, the phenomenon refused complete explanation. The amplitude of the recoil, the persistence of the oscillation, the harmony of the residual gravitational hum, all exceeded predictions. Some speculated a hidden mass, an unseen companion, perhaps even an entire layer of gravitational medium unaccounted for in general relativity. Whatever the cause, the shaken core became more than an object of study. It became a cosmic mirror, reflecting the fragility of order, the motion beneath stillness, the trembling at the heart of even the grandest structures. And so, as telescopes gathered more light, and as algorithms teased signal from noise. Humanity turned not just its instruments, but its wonder toward the question that lingered in the silence. If a black hole, the very anchor of a galaxy, can be moved, then what, if anything, in this universe truly stands still? In the weeks that followed, observatories across the planet continued to track the drifting black hole. Every wavelength told a different story. In X-rays, the displaced core glowed faintly, surrounded by a halo of gas heated to millions of degrees, the remnant shock from its ancient collision. In radio frequencies, vast filaments stretched outward like torn threads of magnetic silk, twisting through the intergalactic medium. These were not random scars, but records the after-images of violence long past, written into the very geometry of space. The pulse detected earlier by the pulsar timing arrays seemed to resonate with the movement of this structure. As the black hole oscillated through its host galaxy, it generated a gravitational hum that spread like sound through a cosmic ocean. It was too slow for human senses, too vast for any single detector to contain. Yet its rhythm aligned eerily with data collected decades apart. Somewhere in the depths of spacetime, the echo of this event was still unfolding, as if the universe itself were replaying its memory in slow motion. As models improved, scientists began to notice something unexpected. The stars near the galactic edge appeared unusually young, luminous, and hot. Their formation accelerated as though the galaxy's imbalance had sparked new creation. The displaced core, in moving through dense clouds of gas, had compressed them, igniting stellar nurseries across tens of thousands of light-years. In its disturbance, life had bloomed anew. This paradox fascinated astronomers. A cataclysm that destroyed order also gave rise to light. It was a cycle written in cosmic logic. Collapse and creation intertwined. What had once been seen as chaos now appeared as a strange form of balance, a natural reorganization of energy. Even the wandering black hole, stripped of its regal symmetry, had become an agent of renewal. And yet, the question of how such a displacement could persist remained unsolved. General relativity predicted damping, a gradual settling back toward equilibrium. But this galaxy refused to stabilize. The motion was continuing, steady and rhythmic, as if an invisible tether were holding the black hole in motion. Some began to wonder whether a deeper layer of gravity was at play, a form of interaction hidden beneath Einstein's equations. A few theorists turned to the idea of modified gravity, the notion that, at intergalactic scales, spacetime might bend differently than predicted. Others proposed a more exotic possibility, that the galaxy was entangled with another system through a cosmic filament of dark matter, and that the motion of its core reflected unseen activity across billions of light-years. If true, the shaken core might be not a solitary event, but one node in a vast interconnected web, the universe itself resonating through invisible threads. But beyond equations and models, the image itself carried a strange beauty. Floating amid the blackness, this super-galaxy appeared like a lantern adrift in eternity. Streams of starlight curved gracefully around its wandering center, tracing invisible gravitational paths. It was a portrait of motion without destination, of power without control. The black hole's trail, captured through composite imagery, resembled a comet's, a faint streak of matter drawn along its wake. But unlike a comet, its journey would take millions of years to complete. Astronomers realized they were witnessing not a single moment, but an epochal event, a celestial migration that might last longer than the age of humanity itself. To some, the phenomenon became a metaphor. The cosmos, in its boundless scale, was not a machine of perfect precision, but a living, shifting continuum, where even the anchors of creation could drift, where gravity, that invisible architect, sometimes faltered, and the universe momentarily forgot its symmetry. And as new simulations extended forward in time, they revealed a haunting vision of the future, the galaxy, slowly stabilizing over another billion years, would eventually realign, but its core would never return fully home. It would continue to oscillate, ever so slightly, a perpetual tremor encoded into the cosmic fabric, a memory of the day when the universe itself was shaken, a black hole that trembled, a galaxy that refused stillness, a universe that whispered through waves of gravity. It was not just an event. It was a reminder that even in the silence between stars, motion is the pulse of existence. 13 billion years ago, the universe was still young, a newborn sea of light and darkness. The cosmic microwave background had barely faded, its afterglow still whispering across the expanding void. Within this haze of hydrogen and helium, gravity began its ancient work. Tiny fluctuations in density, quantum scars from the birth of time, grew into ripples, then tides, drawing matter inward. These ripples became the first galaxies, fragile islands of starlight forming from chaos. Each one was small, turbulent, and restless, a few million stars bound together in swirling halos of dark matter. But gravity is patient, and the universe, though young, was already teaching its oldest lesson, that separation is temporary. The first galaxies collided. They merged, stretched, and folded into one another like luminous currents converging into a single tide. Stars tore through gas clouds, igniting new generations of light as others were swallowed by the black hearts growing in their centers. Every collision was a loss and a rebirth. Over billions of years, this cycle repeated endlessly. Galaxies joined in twos and threes. Clusters formed like cities in the void. And from these cities arose empires, colossal clusters, tens of millions of light years across. The cosmic web took shape, filaments of dark matter stretching across the universe, connecting nodes of light like nerves in a living brain. At the intersections of these filaments, the most massive structures took form, superclusters, vast and intricate, each containing thousands of galaxies bound in gravitational fellowship. But within one of these intersections, something even stranger was brewing. A gravitational sink, deeper than any nearby region, began gathering material at a pace that defied models. What should have been a cluster of galaxies was merging into something singular, a supergalaxy, a luminous continent of stars, born not from calm growth, but from relentless collision. Simulations run by modern cosmologists suggest that this is not impossible. When galaxies collide repeatedly over cosmic epochs, their central black holes drift inward, eventually merging into one. Each merger releases gravitational waves, invisible tremors that ripple through spacetime. And with each tremor, energy is lost, mass is gained, and the system becomes more tightly bound. Over time, such a process could yield a structure beyond anything seen today. A single, galaxy-sized organism containing the remnants of thousands of others, orbiting around a black hole so massive it could unmake worlds with a thought. Astronomers studying extreme systems like IC 1101, one of the largest known galaxies, see hints of this path already. IC 1101 stretches more than 6 million light-years across, its mass exceeding 100 trillion suns. Its central black hole, weighing up to 40 billion solar masses, sits as a gravitational monarch, an echo of what a true supergalaxy might become. But even IC 1101 may be a child beside the colossus, now trembling the universe's gravitational field to imagine the birth of such a behemoth. is to imagine creation at its most violent. Each collision between galaxies tears through trillions of stars. Tidal forces wrench spiral arms apart, flinging stars into intergalactic space. Gas clouds compress, ignite, and explode. In the center, the black holes converge, devouring the debris of their former worlds. The surrounding starlight dims under the weight of their gravity, until what remains is not a spiral or an ellipse, but a sphere of blended light, a cosmic scar glowing faintly in the darkness. And yet, even this is not still. The supermassive black hole at the heart of such a structure grows with every merger, pulling more galaxies inward, reshaping its surroundings with every pulse of gravity. Astronomers call this process galactic cannibalism, though in truth, it is more like the breathing of the cosmos itself. Expansion, collapse, expansion again. Matter consumed, reborn, and rearranged. Following the quiet rhythm of time, in this long arc of growth, one truth emerges. The universe builds by destruction. Stars live and die to forge heavier elements. Galaxies collide to form new architectures of light. And perhaps, in some far future, these supergalaxies, these radiant monoliths of gravity, will themselves merge, until only a few remain, vast, silent, and alone, scattered across a universe grown thin and cold. When theorists model this distant future, they see a cosmos fading into quiet simplicity. Entropy will stretch space until galaxies drift beyond one another's reach. The last black holes will evaporate. The last atoms will fall silent, and all that remains will be the memory, the faint imprint, of motion frozen into the fabric of spacetime, the supergalaxy that now trembles. The cosmos may be both ancestor and prophecy, a glimpse of where all creation ultimately leads. For in every act of growth, the seeds of collapse are already sown. Every expansion carries the memory of the fall. And perhaps that is the universe's final symmetry, that in striving toward magnitude, even the grandest of galaxies begins the long, slow return to stillness. As the models deepened and the simulations refined, the narrative of the Colossus became more than theory. It became a mirror reflecting the universe's relentless hunger for structure. Astronomers began to trace faint clues in the distribution of galaxies, subtle asymmetries that hinted at regions where gravity's hand was far heavier than it should be. In these cosmic basins, entire clusters appeared drawn together faster than expansion models predicted. Something enormous was pulling at them, something older than their light, older perhaps than their individual histories. The evidence was scattered across wavelengths. Infrared surveys from the James Webb Space Telescope revealed diffuse halos of starlight far beyond the visible edges of known clusters, stars flung outward by repeated mergers, forming ghostly bridges between galaxies. In radio, FAST and ALMA detected vast reservoirs of molecular gas, compressed into filaments tens of millions of light-years long. These were the arteries through which new galaxies would someday form, and through which old ones were being consumed. In this architecture, the idea of the supergalaxy ceased to be metaphor. It became a probable stage in the evolution of the cosmos, the logical conclusion of gravity left unchecked by time. Theorists suggested that such structures might exist at the cores of hyperclusters, titanic regions where hundreds of galaxy clusters are slowly collapsing inward under mutual attraction, defying the outward thrust of cosmic acceleration. One such region, catalogued as Able 2029, offered a tantalizing example. At its heart lies IC 1101, but surrounding it are faint gravitational distortions that imply even greater densities beyond. If a single, seamless system were forming there, It would mark one of the largest coherent bodies in the universe, the embryonic form of a cosmic simulations carried out using unbody cosmological models suggested how such a structure might evolve. In the early epochs, dark matter halos merge first, their invisible scaffolding guiding the flow of baryonic matter. As stars and gas settle within this gravitational skeleton, galaxies form along the densest filaments. Over billions of years, repeated mergers erase the original structures, leaving behind a smooth, elliptical envelope glowing faintly with the residue of uncounted suns. The center, meanwhile, becomes a crucible of gravity, a supermassive black hole feeding on the chaos it creates. But amid these calculations, a haunting realization began to take shape. The same processes that give rise to order also guarantee its demise. Each collision increases entropy. Each merger releases energy that cannot be reclaimed. The supergalaxy, for all its grandeur, is a fleeting configuration, a temporary defiance of universal decay. Eventually, even this colossal structure will exhaust its reserves. Its black hole, consuming the last remnants of fuel before the stars, drift into cold isolation. Some scientists began to describe this as the life cycle of gravity. Galaxies are born, they merge, they stabilize, and they dissolve, a cosmic echo of biological growth and death. On cosmic scales, even permanence is illusion. And yet, there is a strange poetry in that impermanence. If one could stand at the edge of such a supergalaxy, billions of light years across, the view would defy comprehension. The sky would blaze with tens of millions of suns, their light blending into a continuous golden haze. No darkness would remain between the stars. Night itself would cease to exist. But the beauty of such abundance would carry its own melancholy, for beneath the light, the slow hum of gravitational exhaustion would already have begun. The colossus would not roar, it would fade. Its black hole, swollen with the memories of galaxies devoured, would one day sleep beneath horizons of absolute silence. The same gravity that built it would, in the end, unmake it. And as the last photons escaped into the expanding dark, they would carry the faintest echo of everything that came before, the light of countless suns, bound once in a single, trembling whole. Even at the universe's grandest scale, creation and collapse are not opposites. They are the same motion, seen from different ends of time. In the thin, dry air of Chile's Atacama Desert, beneath skies so clear that the Milky Way casts shadows, the arguments began. Inside a dimly lit control room at the base of the Alma Observatory, screens flickered with the faint signatures of a gravitational anomaly. A pulse, a rhythm that should not have existed. Some saw in it the mark of something vast, a supergalaxy that had disturbed the very balance of spacetime. Others dismissed it as noise, a distortion born from the imperfect dance between instruments and the cosmos they sought to measure around the world. The signal echoed through data archives. The Subaru telescope in Hawaii, the Very Large Telescope in the Andes, even radio arrays in South Africa, all reported subtle variations in light curves and lensing patterns. Each trace was small, uncertain, but together they whispered of motion in a region where motion should be impossible. At the center of the debate stood Dr. Annika Veras, an astrophysicist whose career had been built on mapping galactic mergers. To her, the data was not a glitch. It was a voice, the deep hum of gravity itself. Her team, scattered across continents and time zones, began comparing measurements, layering frequencies, searching for consistency across instruments. The findings were unnerving. The readings aligned too neatly to be coincidence. But in science, neatness often invites suspicion. Her colleagues warned of lensing artifacts, the bending of light by intervening matter, creating illusions of displacement. Perhaps, they said, the galaxy's apparent imbalance was an optical mirage, a trick of distance and perspective. The more she defended the data, the more resistance grew. Conferences turned tense. Peer reviewers marked her team's papers with cautious skepticism. No known physics allowed for a galaxy to shake a black hole. No precedent justified believing that one could. And yet, the universe had never cared for precedent. Across sleepless nights, data continued to arrive, petabytes of information streaming from telescopes circling the globe. The Event Horizon Telescope contributed radio images of extraordinary resolution, faintly resolving distortions near the galactic center. The Laser Interferometer Gravitational Wave Observatory LIGO, thousands of miles away, began to record an ultra-low frequency pattern far below the range of any known stellar merger. Dr. Verus noticed the timing. The two signals, though separated by method and distance, pulsed together. If it was coincidence, it was perfect. If it was real, it would rewrite everything. For months, the debate turned inward, not just within the scientific community, but within the minds of those who stared too long into the data. To question one's own measurement is a quiet kind of madness. Every possibility balanced between pride and doubt, between the fear of error and the fear of revelation. To see what others refuse to see is a lonely endeavor. In her office overlooking the desert, Dr. Verus kept a printout pinned to the wall, a spectrogram of the anomaly. Beneath the faint pattern, she had written a note to her team: find the silence beneath the noise. Around her, the global effort grew. Teams in Greenland, Japan, and Australia synchronized their instruments to observe the same region of sky, forming a network the size of Earth itself. They began to listen, not just to light, but to gravity, to the invisible trembling of spacetime. Each new observation added another layer to the mystery. The displacement was real, the oscillation measurable, yet still, no explanation fit within the bounds of known physics. Some began to whisper about unverified possibilities, cosmic strings, quantum fluctuations on intergalactic scales, or unseen masses beyond the standard model. But Dr. Verus refused the comfort of fantasy. For her, the beauty of science was not in easy wonder, but in disciplined awe. To stare into the unknown without surrendering to it, and still, doubt persisted. Funding agencies questioned the allocation of resources. Senior colleagues advised restraint. It's lensing, they said, an illusion of light. But at 3 a.m., when the observatory's instruments hummed softly in the cold desert air, and the stars wheeled overhead with ancient patience, even the skeptics paused. There, buried in the data's noise floor, was a tremor, faint, deliberate, impossibly slow. It was as though the universe itself was breathing, exhaling through gravity, waiting to be understood. To study the universe, one of her colleagues murmured one night, is to accept that you might never find yourself again. For every answer uncovered, 100 new questions emerge. Each revelation rearranges the map of what is real, leaving behind a smaller version of the human spirit, humbled, exposed, yet burning brighter for the knowing. The human conflict of discovery is not fought between right and wrong, but between certainty and curiosity, between those who demand the universe fit into equations, and those willing to expand the equations to fit the universe. And so, as telescopes across Earth turned once more toward the trembling core, the team prepared to look deeper, beyond photons, beyond dust, beyond the limits of light itself. Their instruments were tuned not to see, but to listen. For what stirred in that darkness was not a flash, but a vibration, the sound of gravity speaking in its native tongue. And for the first time, humanity was ready to hear it. Night after night, the desert sky became a canvas of silent devotion. Each star, each flicker of radiation, seemed to whisper in riddles, fragments of a cosmic truth buried in the static of time. The observatories pulsed like hearts across the globe, their data streams converging into a single rhythm, the hum of collective wonder. Within that hum, the anomaly deepened. What began as a faint irregularity now took shape as something deliberate, patterned, alive in its precision. The motion of the central black hole was no longer deniable. It drifted slowly, impossibly, against the gravity of its own galaxy. The shaken core, once thought an illusion, now revealed itself as a colossal dance between mass and motion. Like a pendulum carved in spacement, Dr. Verus watched in silence as her simulation models began to fracture under the data's weight. No algorithm could maintain balance. Every calculation, every adjustment collapsed into chaos once the anomaly was introduced. Gravity itself seemed to hesitate, as if reconsidering its own law. Her colleagues stared at the same screen, and for the first time, words failed them. They were no longer questioning whether the phenomenon was real, but whether they were ready to understand what it meant. Was it possible that this galaxy had become so massive, so gravitationally dense, that it was bending not just light, but the very framework of spacetime around it, creating a feedback loop of gravitational resonance? A system where mass and motion no longer obeyed the usual symmetry, where the center no longer held. Theorists began sketching equations that bordered on heresy, models invoking asymmetric dark matter, quantum gravitational drift, even the theoretical concept of negative inertia within supermassive systems. None were stable, yet all hinted at one chilling conclusion. The core of the supergalaxy might not merely be moving. It might be alive in a physical sense, oscillating like a cosmic heartbeat, governed by forces older than known physics. As the weeks turned into months, the data became cleaner. Gravitational wave cross-correlation confirmed a rhythmic pattern, one pulse every few thousand years. A vibration that propagated across millions of light years. A galactic breath. The discovery, though still cloaked in uncertainty, began to spread beyond observatories. Journalists caught whispers of a moving black hole, and governments quietly inquired about its potential effects on nearby spacetime regions. But for Dr. Verus and her team, the focus remained inward, to understand, not to announce. Late one night, as the last data set from the James Webb Space Telescope arrived, a new realization began to take shape. The black hole's apparent drift was not random. It followed a path, a slow, spiraling motion, as if orbiting an invisible center that shouldn't exist. Something unseen held it in place, a gravitational phantom with no detectable mass. Could this be the echo of an ancient collision? The ghost of another black hole long merged, leaving behind a gravitational scar that continued to twist the galaxy's heart. Or was it something even stranger, a remnant of primordial curvature, a ripple born from the first moments after the Big Bang, still vibrating through matter and time? The question hung in the control room air like a low note, a vibration felt more than heard. Every scientist present knew that what they were witnessing wasn't just a discovery. It was a confrontation with the limits of human comprehension. Outside, dawn began to break over the Andes, light spilling across the desert's rust-colored rock. The telescopes stood still, their metallic frames reflecting the first sunlight, their mirrors cooling after a night of revelations. For a fleeting moment, the vast stillness of the universe mirrored the stillness inside those who studied it. A silence that was not absence, but anticipation, because they understood now the universe was not done speaking, and perhaps it never would be. Far beyond, where light from ancient stars still crossed the gulf of billions of years, the shaken core drifted onward, a monument to imbalance, a cathedral of motion within stillness. And though no sound could reach them, those who listened to gravity's faintest tremors swore they could almost hear it, a slow, endless echo, the heartbeat of creation itself. In the darkness between galaxies, the universe breathes through gravity. It is an invisible rhythm, the pulse that binds galaxies, stars, and the atoms within every living being. But in some corners of the cosmos, that rhythm falters. A tremor runs through the void, not born of explosion or light, but of imbalance, a cosmic heartbeat gone irregular. This is the story of how a black hole can move, how the most immovable force in nature, the very anchor of galaxies, can be shaken loose by the universe itself. When two black holes collide, they do not simply merge in silence. The moment of union releases an enormous burst of gravitational waves, ripples in spacetime that travel faster than light ever could, bending the structure of reality as they go. But sometimes the release of this energy is not symmetrical. The waves escape unevenly, like the recoil of a cannon fired into the dark. And the newly formed black hole, heavier, denser, more complete, is pushed away, flung through its host galaxy at thousands of kilometers per second. Astronomers call it gravitational recoil, a simple phrase for a force that can unseat the heart of a galaxy. Real data has revealed such events. Scattered across the cosmic landscape, the quasar 3C 186, a billion light-years away, shows a black hole displaced from its galactic center by more than 35,000 light-years, traveling at nearly 8 million kilometers per hour. In OJ 287, a system of two supermassive black holes caught in a century-long orbit, the smaller one plunges through the accretion disk of the larger every 12 years, creating a flare visible across the universe. Each impact sends ripples not just through matter, but through space-time itself, the echo of a gravitational duet older than humanity. And in the Phoenix cluster, hundreds of galaxies orbit a massive central void, where black holes grow like seeds of darkness in a field of starlight. Their gravitational tides stretch and twist entire clusters, a silent symphony of collisions that will one day merge into something far beyond imagination. But the shaken black hole at the heart of the supergalaxy is different. It does not flee, it wavers. It sways in an immense, slow oscillation, as if suspended between two opposing pulls, each trying to reclaim the center that no longer exists. The phenomenon defies stability models. Simulations suggest that when galaxies of unimaginable size collide, their central black holes might not simply merge, but enter a long, drawn-out gravitational dance, orbiting each other for eons, locked in mutual attraction, yet constantly losing energy through gravitational radiation. Each loop sends out a wave. Each wave disturbs the galaxy's balance, until the entire structure, stars, gas, dark matter, begins to tremble. From billions of light-years away, that trembling looks like a flicker in the fabric of space itself. Light bends unevenly. Background galaxies warp and stretch as if seen through water. In that distortion, astronomers can trace the motion of something invisible, the silent oscillation of a supermassive black hole. The effect is minuscule, almost imperceptible. Yet, over cosmic timescales, it becomes a rhythm, a gravitational bell ringing through the dark. Each oscillation carries memory of the collisions that birthed it, of the stars devoured, of the galaxies consumed. The black hole becomes not just a remnant of destruction, but a living record of creation, the universe remembering its own violence. If the supergalaxy truly harbors such an entity, it means the laws of equilibrium are not absolute. It means that even gravity, the one constant that holds everything together, can stumble when confronted by the infinite. Perhaps, then, the universe itself is not a system of perfect order, but of balance found and lost again and again. Every galaxy a heartbeat, every black hole a pulse, every tremor a reminder that stillness in the cosmos is never truly still. And somewhere, far beyond the edge of known space, the shaken core drifts, its light distorted, its gravity uneven, a galactic heart caught between silence and motion, beating in time with the oldest sound the universe has ever known. Across the dark expanse, the echo of that trembling lingers, a vibration so faint it threads through the universe like the memory of motion. Gravitational waves, stretched thin by distance and time, carry whispers of what happened at the core of the colossal galaxy. These are not the sharp, transient bursts detected by LIGO or Virgo. Those are the fleeting heartbeats of stellar collisions. This is something slower, deeper, a continuous thrum resonating across millions of light years. Pulsar, timing arrays, cosmic clocks scattered through the Milky Way begin to pick up irregularities. Pulsars, the spinning remnants of dead stars, flash radio signals with atomic precision. Yet, their rhythm seems to falter ever so slightly. Each pulse arrives a fraction of a microsecond too early or too late. The deviations align, subtly but consistently, across multiple PULSARS.2 scientists. It's as though spacetime itself is breathing in a new, irregular rhythm, one that cannot be traced to any known source. The pattern matches what would happen if a galaxy-scale gravitational oscillation were rippling through the cosmic web. Theoretical models attempt to map it. Some suggest that the displaced black hole at the center of the supergalaxy could be swinging back and forth through space-time like a pendulum, each pass generating low-frequency waves with periods stretching over decades or even centuries. Others propose that the galaxy itself might be resonating, its billions of stars and clusters subtly shifting under the shifting center of gravity. The visualization is haunting, a galaxy not spinning smoothly, but quivering, its stars rising and falling in imperceptible tides. Light from one edge reaches us milliseconds earlier than light from the other, bending across a space-time fabric that swells and relaxes like the slow inhale of a sleeping giant. Deep field observations from the James Webb Space Telescope add to the enigma. When Webb peers into this region, its infrared instruments reveal something no model predicted, a slight, periodic variation in luminosity from the core, too slow to be a quasar flare and too regular to be noise. Somewhere within the heart of this galactic colossus, light itself seems to respond to an unseen rhythm. If the phenomenon is real, it challenges one of the deepest assumptions in astrophysics, that black holes are static centers of gravity, immovable and absolute. Instead, they may behave more like pendulums of space-time, swinging, resonating, interacting with their surroundings in ways yet to be understood. Within the equations of general relativity, such oscillations are allowed, but only in conditions of extreme asymmetry. To produce the observed scale, two unimaginable masses must have collided, their combined gravitational wave output momentarily unbalancing the space-time curvature around them. The recoil that followed could send the new black hole drifting, then returning, oscillating like a tethered weight at the heart of its galaxy. It becomes an image of the universe in motion, not the perfect stillness of Newtonian harmony, but a living, restless cosmos. Galaxies sway, black holes hum, and light, ever the messenger, carries their trembling across the gulfs of time. Some physicists even speculate that such oscillations might synchronize, that if one galaxy shakes, its gravitational wave could subtly influence another. Over billions of years, these waves might form standing patterns, turning the cosmic web itself into a resonant structure, a universal orchestra playing at frequencies lower than thought, slower than perception. If so, the shaken core is not just an isolated phenomenon. It could be the loudest note in an unseen symphony. As observatories continue to listen, humanity finds itself faced with a possibility both thrilling and unsettling, that the universe is not silent, but filled with deep, ongoing music, vibrations so vast that only the language of gravity can carry their sound. And within that eternal song, a single black hole, displaced but not destroyed, moves like a solitary drumbeat, echoing through eternity, reminding the cosmos that even its darkest hearts can tremble. Beyond the reach of light, where silence reigns and time itself slows, the frontier of human understanding thins. Every telescope, every detector, every equation, they all press against that invisible border, the edge of science. Here, the universe speaks, not in photons, but in the slow, rolling waves of space-time, the language of gravity itself. For centuries, light had been the only messenger. It revealed the birth of stars, the death of galaxies, the afterglow of the Big Bang. But light is easily silenced, trapped inside event horizons, absorbed by dust, scattered by time. Gravity, however, passes through everything. It is the pulse of the cosmos, moving unseen through matter and memory alike. When the first gravitational waves were detected in 2015, humanity heard for the first time the sound of two black holes colliding. That single whisper confirmed Einstein's predictions from a century earlier and opened a new sense, a way to listen to the fabric of reality. Now, at the edge of perception, that same sense begins to hear something stranger, a low, continuous signal, not sharp, not transient, but patient, a hum too vast to come from any known merger. Pulsar timing arrays, deep space interferometers, and orbital observatories have all caught fragments of it, smeared through cosmic noise, buried beneath the heartbeat of the universe itself. Filtering it is like isolating one wave in a restless ocean. The signal stretches across years of data, its amplitude fading, rising, then fading again, an echo that refuses to vanish. When researchers apply models of general relativity, the results almost make sense, almost the patterns fit, but only at first. Then the equations begin to bend, the curves fall out of alignment, as though the rules themselves are flexing to accommodate something unseen. Some suggest interference. Others whisper of dark matter. Perhaps the gravitational waves are not traveling through empty space at all, but through filaments of unseen mass, the cosmic web's skeleton, made of dark matter and energy. In such regions, space-time would not behave as a smooth fabric, but as a viscous medium, thickened by invisible substance. A wave passing through might slow, distort, amplify, and if a black hole were oscillating within such a field, the resulting pattern could look like an impossible tremor, a resonance between matter and the UNOB server. It is an idea that stretches Einstein's theory toward its breaking point. General relativity, though perfect in prediction, remains silent on what gravity is. It tells how it behaves, how it bends light, how it guides planets and stars, but it never reveals its essence, its origin, or its limit. In the extreme conditions surrounding a supergalaxy's heart, those limits may finally emerge. If the gravitational oscillations seen here truly deviate from relativity, they could mark the first observational hint of a deeper framework, a bridge toward quantum gravity, or perhaps something stranger still, a direct interaction between spacetime and the dark sectors of the cosmos. For now, such ideas remain whispers. No instrument can yet confirm them, but the patterns persist, consistent across independent data streams, as though the universe itself is insisting on being heard. The scientists who stare into these signals find themselves at a crossroads, familiar to every era of discovery, where data ends and wonder begins. They are forced to confront an old truth, that understanding is not a wall to be reached, but an endless horizon that recedes with every step closer. In this trembling galaxy, something ancient and immense seems to move, not in defiance of physics, but in invitation to expand it. A motion that does not destroy, but questions. A vibration that hums just beyond the frequencies of comprehension, urging those who listen to follow. The universe remains half hidden, its greatest truths whispered, not shown. And somewhere, in the dark between the galaxies, a ripple moves slow, deliberate, eternal, shaking not only a black hole, but the foundations of knowledge itself at the farthest limits of detection. The signal persists, faint, elusive, yet deliberate. It pulses not with the rhythm of a collision, but with something older, steadier, as though it has been resonating since the universe's youth. Researchers lean closer, not with instruments, but with imagination. They know that each new frontier in science begins as noise, a faint murmur dismissed by certainty until it refuses to fade. This tremor has refused to fade. Weeks turn into months as observatories recalibrate, filtering cosmic static through supercomputers that hum like digital hearts. The data is passed, corrected. The signal remains. It spans such vast scales that no single event can explain it. It behaves neither like a merger nor a quasar flare. Instead, it resonates with a rhythm measured not in seconds, but in centuries. Theories emerge cautiously. Perhaps the black hole's oscillation is coupled with something beyond its host galaxy, perhaps. An unseen gravitational filament connects it to others. Across the cosmic web, modern cosmology describes that web as a vast network of filaments, bridges of dark matter and hydrogen that bind the universe together, stretching between galaxy clusters like the tendons of creation. Simulations reveal that these filaments can vibrate, subtly transmitting gravitational energy from one end to another, much like strings drawn tight across the void. If a supermassive object were to move within one of these filaments, it could, in theory, send a wave rippling through the structure, affecting distant galaxies connected by the same dark thread. The thought is staggering, that the trembling of a single galactic heart could send echoes through millions of light years. The cosmos, itself quivering in sympathy, but within the laboratories and observatories where this data is studied, not everyone agrees. The mathematics becomes fragile here. General relativity, elegant, consistent, nearly divine in its precision, begins to unravel when pressed beyond the scales it was built to describe. It explains the curvature of space, the behavior of light, the orbits of planets, yet it hesitates at the border of the infinite. Beyond that, quantum uncertainty reigns, a world of probabilities, where gravity is not a curve, but a vibration, not a fabric, but a field. The two languages of physics, both perfect in their own domains, refuse to speak to one another. This mysterious signal seems to speak both at once. Its persistence hints at continuity, yet its distortions hint at quantum irregularity. Could it be that within the shaken galaxy, the black hole's motion stirs something beneath the visible cosmos, an interface where spacetime meets its own foundation? Physicists have long theorized about quantum foam, the turbulent, microscopic sea beneath reality's smooth surface. At that scale, space and time flicker like particles themselves. If a gravitational wave of immense amplitude passed through such foam, the interaction might amplify or distort it, an echo from the smallest realm, magnified into the largest. The possibility is haunting. It suggests that the oscillation may not be entirely cosmic in origin, that what the telescopes detect could be spacetime revealing its hidden texture. If true, the shaken core would not merely be a celestial event, but a window into the fundamental structure of the universe. For the first time, astronomers might be observing the interface where gravity and quantum mechanics converge, the very place where the known universe folds into the unknown. Late at night, in quiet control rooms lit by the glow of monitors, the scientists watch the data streams continue their slow dance. There is no applause, no certainty, only an awareness of scale, of what it means to confront the limits of understanding. Every line of data, every flicker in the spectrum, is a whisper from the cosmos asking a question that no equation can yet answer. For all the sophistication of their instruments, they are still children listening for thunder beyond the horizon, hoping to understand the storm that made it. Somewhere in the dark, the black hole drifts, neither at rest nor entirely free, suspended between motion and memory. Its pull shapes not just the stars around it, but the thoughts of those who dare to imagine what lies beyond their reach at the edge of science. There are no borders, only thresholds, and the courage to cross them. The signal continues, faint but enduring, tracing a shape across the invisible. It is not chaos. It is not order. It is something between a reminder that the universe is neither finished nor fully begun, and that perhaps every tremor in the dark is an invitation to listen more deeply to the silence itself, in the quiet heart of the cosmos. Stability is an illusion. Every galaxy, every radiant swirl of stars carries within it a restless core, a gravity so immense that it binds time itself. Yet even this anchor, this cosmic certainty, can move. In the aftermath of a colossal merger, when galaxies entwine and their central black holes spiral toward one another, the universe briefly forgets its own balance. It trembles. Astronomers have long suspected such moments occur, not as violent bursts of chaos, but as symphonies of immense precision. Through simulations run across supercomputers spanning continents, the evolution of galaxies has been replayed countless times. Two spirals approach, drawn together by gravity's ancient pull. Their stars distort, their shapes stretch like fluid under pressure, and at their centers, the supermassive black holes begin an invisible dance. They circle each other in a tightening orbit, losing energy through gravitational radiation waves in spacetime itself, until in a single breath of cosmic time they merge. The collision is silent but absolute. In the briefest instant, energy equivalent to millions of supernova erupts as gravitational waves that ripple across the universe. Yet the explosion is not symmetric. Like an unbalanced bell struck too hard, the newborn black hole recoils, shot across the galactic center at thousands of kilometers per second. This is gravitational recoil, a phenomenon first predicted through Einstein's equations, later refined through simulations by the Oneo-Grav and LIGO collaborations. It means that even the heaviest objects in existence, once thought immovable, can be set adrift. Such events are not theoretical curiosities. Observations from the Sloan Digital Sky Survey and the Chandra X-ray Observatory have revealed galaxies where the central black hole appears offset, displaced by light years from the heart of its home. In one striking case, the quasar 3C 186, located nearly 8 billion light-years away, shows a brilliant active core hurtling through space at nearly 2,000 kilometers per second. Astronomers believe it is the visible mark of a black hole kicked from its nest by gravitational recoil. The very heart of a galaxy, torn free, now wanders through the void, dragging its accretion. Disk and cluster of loyal stars behind it, like the fading tail of a comet, at scales beyond imagination. These migrations reshape the galaxies themselves. Without a central anchor, stellar orbits begin to drift. The bright spiral arms loosen. The gravitational symmetry fades. Over millions of years, the galaxy settles into a quieter, more irregular form, a cosmic echo of what it once was. Some simulations suggest that such ejections could explain why many galaxies appear to have smaller or less active cores than expected. The universe may be littered with orphaned black holes, silent, invisible travelers drifting between galaxies, unseen except for the occasional flicker of starlight they consume. Meanwhile, on Earth, instruments like the unanagrave pulsar timing array and the Event Horizon telescope EHT listen for evidence of these invisible migrations. Unanagrav detects the faint trembling of spacetime through the rhythmic pulses of distant neutron stars, cosmic metronomes whose slight variations betray the passing of gravitational waves. In 2023, the collaboration revealed signals suggesting a background hum of gravitational waves rippling across the universe, perhaps the collective song of thousands of merging supermassive black holes, each one a verse in a cosmic requiem. The EA, meanwhile, peers directly into the abyss. Its composite view of M87 and Sagittarius A, the first images ever captured of a black hole's shadow, confirm that these monsters are real, tangible, and dynamic. Within those halos of fire and shadow, space-time bends back upon itself, creating a living portrait of Einstein's predictions. The images, though beautiful, are more than symbols of discovery. They are proof that the most powerful forces in existence are not theoretical ghosts, but sculptors of reality. And yet, beneath the triumph of understanding, a quiet unease lingers. If galaxies can lose their centers, if even black holes can be displaced, then permanence itself becomes suspect. Gravity, once seen as the universe's great stabilizer, reveals its capacity for disorder. The cosmos, it seems, is not a structure, but a performance, a dance of balance and imbalance, of order perpetually interrupted. Perhaps the truth is not that galaxies are shaken by chance, but that motion, even chaos, is their natural state. For in the vast silence between stars, nothing remains still for long. The black hole that drifts through intergalactic darkness carries with it the memory of creation's violence and the promise of renewal. It is not destruction that defines the universe, but movement, the constant reshaping of what is known into what might be in this light. Stability is not the universe's nature, but its illusion, a brief pause in an endless rhythm of collapse and awakening. And as astronomers study these cosmic wanderers, they begin to glimpse a truth as old as time, that even the universe's darkest hearts are still in motion, still searching for their place in the infinite. But beyond the instruments, beyond the data, there is an older realization rising quietly in the background, one that echoes through every discovery humanity has made about the heavens. The more deeply science peers into the cosmos, the more it finds that balance is fragile and permanence is a myth. Even the supermassive hearts of galaxies, once thought eternal, tremble to forces far older and grander than themselves. And in that trembling lies the universe's truest rhythm, not a steady pulse, but a cosmic heartbeat that occasionally stutters, pauses, and begins again, in supercomputer simulations run by cosmological teams across NASA's Goddard Space Flight Center and the Max Planck Institute. Entire universes unfold in digital form. Within them, galaxies weave together like drifting clouds of light. When to collide, their stars barely touch. Yet their dark matter halos and black holes collide in ways that defy human intuition. As they merge, the very fabric of space ripples, invisible waves traveling for billions of light years, stretching and compressing spacetime like a breathing organism. And when the waves pass, the new galaxy formed in their wake trembles, as though remembering the violence that created it. In these simulations, gravitational recoil is not a mere mathematical artifact, but a living consequence. A small imbalance in the release of gravitational energy, just a fraction of a percent, can launch a black hole out of its cradle. Some are pulled back by the galaxy's gravity after millions of years, oscillating through the core like a pendulum. Others, however, escape entirely, sailing into the intergalactic void where not even starlight follows. If one could stand upon a hypothetical world orbiting such a runaway black hole, they would see a universe stripped of all direction, a lonely, drifting eternity with no sun, no horizon, only the faint relic glow of the cosmic microwave background whispering of what once was. Observations from X-ray telescopes and deep space. Surveys are beginning to support this strange possibility. The Chandra and XMM Newton observatories have found faint, off-centered X-ray sources in distant galaxies, signals that may belong to black holes in mid-flight. Even more curiously, gravitational wave detectors are hinting at mergers occurring far from galactic centers, as if the black holes responsible were already displaced before their union. It paints a picture of a universe far less orderly than once imagined, a cosmos built not on symmetry but on aftermaths. And within those aftermaths lies a haunting implication. If supermassive black holes can drift, then the galaxies they once governed must evolve differently. Without their gravitational overseer, the dense central bulge of stars loses its cohesion. Over billions of years, it may flatten or disperse, its stellar population fading into the halo. The galaxy's rotation curve changes, its structure softens. Even the cycle of star formation, once regulated by the feedback of the central black holes, energy begins to shift. The cosmic ecosystem, from star birth to star death, transforms simply because its heart has moved. Yet there is beauty in this instability. For every wandering black hole, another finds its home anew. Some theories propose that rogue black holes traveling between galaxies could seed new systems. By capturing passing gas and dark matter, they might ignite a new phase of star formation in the empty spaces of the cosmos, an act of creation born from displacement. If so, then even exile in the universe has purpose. Destruction becomes reformation. Drift becomes genesis. The mainstream theories that attempt to explain these phenomena, the binary mergers, the gravitational recoil, the oscillations within galactic cores, represent the most advanced frontier of astrophysical understanding. Yet beneath their mathematics lies something profoundly human, the recognition that nothing, not even the universe's greatest structures, escapes impermanence. Every galaxy, every star, every atom carries within it a trace of motion, an ancient whisper that says, change is the only constant. As telescopes sharpen and detectors grow more sensitive, humanity inches closer to seeing these truths not as abstractions, but as living realities. Somewhere deep in the observable universe, a supermassive black hole is moving still, gliding through the dim corridors of intergalactic space, its mass bending light into an ethereal halo. It may never stop. It may never return, but through it, the universe reminds us of a quiet law written in the fabric of existence, that even the mightiest are not fixed, and that movement, not stillness, is the signature of all creation. And perhaps that is what makes the cosmos so hauntingly beautiful, not its grandeur, nor its violence, but its refusal to remain still. Every trembling galaxy, every drifting core, every echo of a gravitational wave tells the same story, that existence itself is motion, endless, restless, eternal, in the quiet halls of theoretical physics, where equations become poetry and symbols speak of creation. A new frontier begins to shimmer, the realm where known laws bend toward the impossible. Here, speculation does not mean fantasy. It is the delicate act of reaching beyond what observation allows, into the invisible geometry of existence. The signals once dismissed as noise now carry whispers of something greater, something the universe itself may not yet have finished revealing. Some researchers believe the disturbance shaking the galactic core may not stem from a merger at all, but from a deeper conversation within spacetime, a resonance between gravity and the vast cosmic web that stretches across the universe. In this model, every galaxy, every cluster, is a node in an immense gravitational lattice. When one node trembles, when one black hole shifts, or one cluster collapses, the entire web vibrates, not as a simple echo, but as a standing wave through the structure of existence itself. The fabric of space-time becomes a kind of cosmic instrument, tuned by mass, tensioned by dark matter, played by the unseen hand of dark energy. The theory of gravitational resonance arises. Here, a proposal that the great structures of the universe, from galaxies to filaments, can resonate with the quantum fields that define spacetime. The frequencies are unimaginably low, cycles spanning millions of years. Yet, in that slow pulse, some physicists hear the heartbeat of creation. The idea finds faint support in anomalies detected by pulsar timing arrays, long rhythmic delays in pulsar signals that seem to align across billions of light years. These are not bursts or collisions, but waves of something vast, too coherent to be random, too deliberate to ignore. To those who dare to model it, the math is both beautiful and cruel. Einstein's general relativity bends under the weight of quantum mechanics, and somewhere between them lies a riddle. Could gravity, at its deepest level, be not conscious in a human sense, but self-reactive, capable of feedback, memory, and vibration? In this view, space-time itself becomes a living field, storing imprints of every cosmic event that has ever occurred. When something colossal happens, the birth of a black hole, the collision of galaxies, the universe does not merely record it, it hums with the memory. What the observatories detected then might not be a new event at all, but the afterglow of the universe remembering itself. Among the most daring hypotheses stands the concept of gravista's exotic objects that could exist where black holes should be, formed when collapsing matter encounters a counterpressure from dark energy. Instead of forming a singularity, the collapse halts, creating a dense shell of quantum vacuum energy surrounding a hollow core. These theoretical bodies would mimic the gravity of black holes, but behave differently under extreme interactions, capable, perhaps, of releasing gravitational echoes when perturbed. If such an object lay at the center of the shaken galaxy, Its behavior might explain the strange oscillations without violating relativity. The challenge: no one has ever observed a gravistar, and their existence remains purely theoretical. Yet, the deeper the anomalies go, the harder it becomes to dismiss the possibility. Even more radical ideas begin to surface, suggestions that dark energy itself, the mysterious force accelerating the expansion of the universe, might not be a constant background, but a dynamic field capable of interacting with massive structures. Some quantum cosmologists propose that when immense gravitational wells, such as black holes or galactic clusters, move through regions of fluctuating dark energy density, they could experience a temporary tug, a subtle exchange of energy that alters their motion. The result would be an oscillation, a pulse in the void, a gravitational whisper recorded by our instruments as a low, steady hum. To think this way is to stand on the edge of known science, where the firm ground of data gives way to the soft horizon of imagination. Yet it is imagination disciplined by mathematics, bound by observation, tethered to the faint but undeniable signals arriving from the cosmos. Each theory, no matter how speculative, is a mirror reflecting our desire to understand the universe not just as an object of study, but as a living, evolving story. And within that story lies a profound humility. The more humans uncover, the more the cosmos seems to withdraw, revealing only fragments, never the whole. The idea that spacetime itself might remember, that the universe carries a kind of resonance through eternity, shifts the perspective of what it means to observe. Humanity is not just watching the cosmos, it is listening to the echoes of its own beginning, to the slow fading chorus of creation's first note. Somewhere, hidden beneath the noise, the data may already contain the truth. But even if that truth remains forever out of reach, it has given something invaluable, a glimpse of the infinite complexity that lies behind what is seen, and a reminder that the universe is not a static structure, but a symphony still playing itself into being. Theories will come and go, names will fade, but the resonance that trembling through space and time will remain, carrying forward the story of everything that ever was, and everything still becoming, across the cosmos. The search for meaning in the tremor continues, not as a race for proof, but as an act of reverence. The signals persist, faint and uneven, bending with the drift of time, whispering of a mechanism too vast for the human mind to hold all at once. In laboratories and observatories, equations become hymns to the unknown, and each dataset a kind of scripture written in the language of gravity. What these scientists study is not only the behavior of the universe, but the rhythm of existence itself, the possibility that every atom, every star, every gravitational wave is part of a single, unending vibration that began with the Big Bang and has never truly ceased. Some simulations suggest that if enough mass aligns along the filaments of the cosmic web, the structure could momentarily act as a resonant cavity, amplifying distortions in space-time in the same way a cathedral amplifies sound. Galaxies, scattered across billions of light years, could then behave as harmonic nodes in a cosmic symphony. The tremor from the shaken galaxy might not be isolated. It could be one note in a grander chord, vibrating through the dark matter scaffolding that connects all galactic clusters. In this vision, the universe becomes not merely a space of stars, but a resonating body, a cosmic instrument still echoing the first sound ever made, the primordial wave of creation. To test such ideas demands instruments far beyond human reach. Gravitational interferometers strung across planetary distances, sensors suspended in interstellar space, free from the noise of Earth. Yet even the limited observatories of today, LIGO, Virgo, Cagra, Unyanograv have revealed a subtle truth. The universe is restless. The fabric of space-time is not silent. It quivers with a continuous low-frequency murmur that cannot be traced to any single event. Some call it the gravitational wave background, a collective song from countless cosmic collisions. But others wonder, what if part of that background is not the sum of many events, but the voice of the cosmos itself, a self-sustaining resonance, a memory of the universe learning how to exist. The notion that reality could hold memory within its curvature challenges the boundary between physics and philosophy. In quantum theory, every interaction leaves a trace, information that cannot be destroyed. If this law extends to gravity, then perhaps the universe's expansion, its accelerating drift into coldness, is not a decay but a form of preservation. Every vibration, every gravitational pulse, carries the signature of what once was, stored in the architecture of space-time like a vast, invisible archive. The shaking of the supergalaxy, then, might not simply be a disturbance of mass and energy, but the reawakening of an ancient pattern, a ripple that began before galaxies existed, now replaying itself across eons. The speculative becomes almost spiritual here, not in defiance of science, but as its natural evolution. The more complete the equations become, the more they resemble poetry. The curvature of space, the flow of time, the vibration of energy, all begin to sound like verses of a cosmic hymn, sung in frequencies beyond perception. Some theorists quietly confess that what they chase in the data is not a final answer, but a sense of belonging in a universe that endlessly transforms, yet never forgets. In the long halls of deep space research centers, supercomputers model the interaction between dark energy and gravitational waves. Patterns emerge, faint correlations where none should exist. In these digital universes, space-time ripples like water struck by wind, carrying interference patterns that dance in harmony with dark energy density. It is as if one field listens to the other, and when the music aligns, something in the void stirs. Perhaps what was seen, the galaxy that shook its own black hole, was not a coincidence, but a rare moment of resonance, where the forces that sculpt the cosmos briefly came into tune. And yet, the deeper the models go, the more profound the silence that follows. For every answer, 10 new mysteries appear. The scientists' graphs flatten into questions too vast for mathematics. Could the tremor be evidence of a deeper layer of physics, one that connects gravity, quantum fields, and consciousness itself? If the universe is capable of vibration and memory, could awareness, in some diffuse, cosmic sense, be an emergent property of space-time? Such thoughts remain unspoken in formal papers, confined instead to the quiet hours when data flickers on the screens and the universe feels impossibly near. The mystery of the shaking galaxy becomes more than an astronomical curiosity. It becomes a reflection of everything humanity has ever sought, a reminder that knowledge is not a conquest, but a communion. The cosmos does not surrender its secrets easily, but every signal, every ripple, is an invitation to listen closer. And so, humanity listens to the faint hum of distant gravity, to the deep, resonant breath of the universe, and somewhere, between silence and discovery, between what can be known and what must be felt, the next revelation waits, trembling at the edge of perception, in observatories across the world, buried beneath mountains, floating in orbit, or humming quietly on icy plateaus. The universe is being listened to, not with ears, but with gravity itself. Every signal that trembles through space-time is captured, filtered, and analyzed, in search of the same elusive rhythm that once echoed from the depths of the cosmos. the tremor that shook a black hole. Years have passed since the first anomaly was recorded. Yet even now, the data still breathes with its ghost, faint, uncertain, like the echo of a heartbeat fading into the dark. Humanity continues to listen, refining the silence, learning how to hear what lies beneath it. The search now unfolds on multiple frontiers. In the high desert of Chile, radio telescopes trace the faint timing of millisecond pulsars, stellar remnants spinning with the precision of atomic clocks. Across the globe, supercomputers analyze variations in their pulse arrivals, measuring shifts as small as a fraction of a nanosecond. These shifts, when compared across hundreds of pulsars, can reveal waves stretching across the universe, gravitational undulations rippling through the fabric of space. And in those delicate tremors, some believe the faint residue of the shaken core still lingers, a pattern buried in cosmic noise, waiting to be heard again soon. Humanity's reach will extend even farther. The Laser Interferometer Space Antenna, or LISA, is being prepared, a constellation of spacecraft that will drift millions of kilometers apart, connected by beams of light thinner than thought itself. It will not look at the stars, but through them, sensing movements too deep for light to reveal. LISA will listen for gravitational waves that take years to complete a single cycle. The slow-motion heartbeat of galaxies themselves. Somewhere in that range, between the hum of merging clusters and the background murmur of the cosmos, may lie the frequency of the original tremor, a signal vast enough to bend galaxies, slow enough to be almost eternal. But even as technology advances, the mystery grows more complex. The more clearly scientists can see, the more contradictions emerge. Models of galactic dynamics suggest that if the supergalaxy truly displaced its central black hole, the recoil energy should have torn apart its core, yet observations show stability. The equations hold and break in the same breath, suggesting that something unknown counterbalances the chaos. Some theorists point toward dark matter halos, invisible oceans of gravity that cradle galaxies in unseen hands. Perhaps, they say, the tremor was not a collapse, but a resonance. The dark matter, itself vibrating in harmony with its luminous counterpart. Inside the servers of international data centers, simulations unfold like miniature universes. The Milky Way, Andromeda, and thousands of imagined galaxies collide and merge, guided by the mathematics of relativity and chaos. On the screens, the centers of galaxies sway, oscillating as their black holes dance around one another in spirals of light and shadow. For a moment, the data becomes almost alive, a visual echo of the cosmic tremor that started this quest. Scientists pause to watch, not as analysts, but as witnesses to something almost poetic. Matter, motion, and meaning intertwined. Beyond the data lies a quiet transformation in thought. What began as a technical problem, a strange fluctuation in gravitational readings, has become a mirror held up to humanity's deepest instinct, the need to understand what cannot be seen. Modern astronomy now stands at the intersection of science and art, where equations become stories and instruments become extensions of imagination. The boundaries between observation and interpretation blur, and the act of discovery becomes an act of reflection. Each new generation of telescopes brings the universe closer, but also reveals how little can ever truly be known. The deeper the instruments reach, the more they encounter the limits of perception itself. What if the cosmos hides not because it is distant, but because it is infinite, its truths diffused across every scale of reality, too vast to ever be contained in one observation, one equation, one mind? And still, they search, The pulsars continue to beat their mechanical hearts. The data continues to whisper. The universe, vast and ancient, remains patient, watching as its observers inch closer to the edge of comprehension. Somewhere in that darkness, perhaps in a signal not yet recognized, the same tremor that once disturbed a black hole may still be traveling, a ripple older than memory, slower than time, reaching outward from the moment creation first began to move. It is not only a search for a sound or for proof. It is a search for meaning, for the moment when gravity itself flinched, when the immovable was moved. And in that pursuit lies the essence of science, a longing not merely to measure the universe, but to feel its pulse. For as the instruments grow more precise and the data more profound, the cosmos seems to lean closer, whispering a question as ancient as existence itself. What, after all, can truly shake the unshakable? Perhaps the answer lies not in force, but in harmony. As the universe expands, it hums with invisible tension, a balance between gravity pulling inward and dark energy pushing outward. This equilibrium, delicate and immense, may itself be capable of vibration. Some physicists suggest that if space-time can flex under gravity's influence, then the very scaffolding of reality could resonate under certain cosmic conditions. Like a drum stretched across infinity, it might respond to great events, the collision of galaxies, the birth of quasars, or the merging of black holes, with deep, reverberating tones that echo for eons. New generations of detectors, more sensitive than any before, are being tuned to listen for these low cosmic frequencies. Across continents, arrays of radio dishes point toward millisecond pulsars, seeking infinitesimal distortions in their rhythm. Meanwhile, quantum experiments on Earth attempt to measure space-time at its smallest scales, probing whether gravity itself has a granular texture, a quantum heartbeat hidden beneath relativity's smooth surface. If these patterns could be correlated, it might reveal that the universe is not merely reacting to motion, but participating in it, a living fabric that remembers every event within its folds. In the halls of theoretical physics, whispers of possibility ripple through discussion. Some propose that gravitational waves might interfere with one another, creating standing patterns, resonant modes of the universe, where space-time hums like a violin string tuned by cosmic events. These patterns, if detected, could serve as a kind of celestial memory, storing the history of motion and mass across the eons. Others extend the thought further, suggesting that such resonance could interact with the dark energy field itself, producing fluctuations that mimic or mask the signals we interpret as black hole mergers. To model such phenomena, supercomputers now simulate universes not of matter alone, but of space-time's fabric itself, rippling, folding, and vibrating under unseen pressures. Each simulation consumes months of computation, billions of calculations per second. Yet even these are fragments of a deeper truth. They show how small changes, a phase shift, a density wave, a quantum fluctuation, can alter the fate of entire galaxies. In one model, a single gravitational wave passes through a virtual cluster, and the cluster's core begins to oscillate, like a pendulum pushed by an unseen hand. The scientists observing it cannot help but pause, wondering if somewhere, long ago, the real universe experienced the same. For all the equations and sensors, there remains a profound humility in this work. Every discovery seems to uncover a larger mystery, every answer an unseen door. The tremor that once shook a black hole has become more than an event. It is a symbol of the universe's ability to surprise, to defy even its own rules. It reminds humanity that perhaps the cosmos is not a static mechanism, but a symphony, one still unfolding, still improvising, guided by harmonies no consciousness yet fully understands. And so the search continues, stretching through radio waves, through gravitational maps, through silent chambers of quantum laboratories. Each new observation adds a note to an unfinished melody, one composed in the language of curvature and light. Some nights, when the detectors fall quiet and the data settles, astronomers imagine the sound of that melody, deep, slow, timeless. They imagine what it would mean to finally hear the rhythm of creation itself. In that thought lies both wonder and humility, that humanity's greatest instruments may one day catch a fragment of the universe's own voice, not the sound of stars or collisions, but the resonance of existence, a faint vibration that began when time itself took its first breath. Perhaps the tremor that shook a black hole was not just a singular event, but a message, an ancient pulse, still crossing the cosmic sea. If so, the search for it is more than science. It is communion, an act of listening across eternity, for the heartbeat of the infinite. In the deep silence between galaxies, the tremor returns, faint, ancient, familiar. It echoes not through air or matter, but through the bones of spacetime itself. Somewhere, far beyond the veil of light, a memory stirs, the aftershock of creation, the pulse that once rippled through the newborn universe. What began as the violent union of black holes, as galaxies colliding in cosmic ballet, now reveals itself as something deeper, a reminder that even the infinite is not still. The cosmos, vast and unbroken, trembles softly, as though remembering its own beginning. The so-called supergalaxy, that colossal merger of stars, dust, and singularities, stands not merely as a structure of matter, but as a metaphor. It is motion within stillness, chaos folded into symmetry. Around its luminous core, hundreds of billions of suns swirl in quiet obedience to gravity's unseen hand. Yet, at its center, the black hole, the heart of darkness, quivers, displaced by its own creation. This motion, this subtle oscillation through space-time, mirrors the universe's first vibrations, the quantum fluctuations that once sparked the birth of everything. Entropy, creation, and decay form the eternal cycle. Stars burn to ashes. Galaxies collide and are reborn. Even the void itself is not empty. It seethes with invisible energy, the restless breath of existence. To study these tremors is to witness the universe in conversation with itself, whispering the language of transformation. Each wave, each oscillation, is a syllable in the cosmic story, a reminder that nothing, not even darkness, remains truly still as telescopes refine their gaze and detectors stretch their senses. The search continues for that original vibration, the faint gravitational echo that may yet carry the signature of the Big Bang, the laser interferometer space antenna, still in preparation, promises to listen across millions of kilometers, tuned not to light but to the deep music of gravity. And in that effort lies a strange humility that even the grandest minds, with all their equations and machines, are only learning to hear what the universe has been singing since the dawn of time. For in the end, the cosmos is not cold machinery, but resonance. The galaxies themselves seem to breathe, expanding, contracting, colliding, reforming as though caught in the rhythm of an ancient pulse. When one black hole trembles, the effect ripples outward, carried across eons. It reaches the edge of perception, brushing against the fabric of human thought. The same laws that bind galaxies also shape consciousness. The same entropy that dissolves stars fuels the flicker of awareness. The connection is not metaphorical, it is physical, elemental. Humanity, too, is woven from the same trembling energy. The universe shakes, and within that tremor lies emotion, if not in the human sense, then in a cosmic one. Each vibration is a release, a reminder of imbalance seeking harmony. Just as the human heart trembles at the weight of wonder or grief, so does the cosmos quiver under the tension of its own birth. The parallels are haunting. Both are acts of remembrance, signs that something within the void is alive, aware and still in motion. Across the great dark, the gravitational waves continue their silent journey. They pass through galaxies, through stars, through the atoms of every observer. They move through oceans, through stone, through the space between moments. They move through time itself, and though imperceptible, they are constant. The universe, in all its vastness, still hums from the touch of its own creation. And so, the story ends where it began, with a tremor in the dark. The supergalaxy fades into the deep, a colossal silhouette against eternity. Its light will travel for billions of years before reaching another mind capable of wonder. Yet the motion remains, eternal and unseen, like the pulse beneath silence. Perhaps, when the instruments fall quiet and all equations fade into noise, only one truth will remain, not in data, but in feeling, that the universe shakes not because it is breaking, but because it remembers. Each vibration, each gravitational whisper, is the cosmos reliving its first breath. A shudder not of destruction, but of memory. As the screen fades to black, only one ripple remains, stretching outward, across time, across stars, across the unending sea of existence. A single heartbeat of creation, still traveling, still alive. The ripple drifts endlessly, threading through the great lattice of existence. It passes through the dim halos of distant clusters, through tendrils of dark matter that bind the cosmos like invisible rivers. Every atom it touches remembers that it once belonged to a universe still aflame with birth. And in that touch lies a question older than stars. Can memory exist without consciousness? Or is the universe itself the dream of its own becoming? Far from human sight, the gravitational wave stretches, weakens, yet never dies.